Okay, next topic is composite function, and this is also known as function of a function. Okay, simple. Actually, see, g of fx function, g of fx is said to be composite function. This is the composite function, function of a function. Okay, function g of fx is said to be composite function of g and f. Okay, this is the composite function of these two functions g and f, and is denoted by z of f. Okay, or simply GOF. Z of f, this one is denoted, g of fx is denoted by z of f. Okay, it is also known as function of a function. Okay, so if it is given that g of fx, it means z of fx. Similarly, f of gx, it means f of gx. Okay, now actually I have some points about this composite function. Okay, it means actually if this one is function na, then we have to remember things about domain, range when this one is defined. Okay, so first I am drawing pictorial diagram for this one. Okay, now suppose if you want to get g of fx, then in function what we are doing, we have to just put a value of x, then you will get a value of y. Okay, that is the rule of function. Okay, put a value of x, then you will get unique y. Okay, so to get g of fx, suppose I am putting any value of x, then first this x is received by f. Okay, simply na, suppose this is machine or function f. Okay, rule of function and machine is same thing. So x is received by f, then what you will get? Then you will get f of x. X goes to f, then you will get f of x. Then this f of x is received by z. Okay, or this f of x is goes to z. Then finally what you will get? G of fx. Okay, like this one. Okay, now see, I want to write some point. Can I say that first in this composite function g of fx, first x is received by f, then f can't accept any value that is not present in domain of f, or that is not belongs to domain of f. For example, okay, suppose I am taking g of x is equals to sin x and f of x is equals to ln x, for example. Okay, only na, then if you find g of fx, at the place of fx, g of fx na, fx is ln x, g of ln x, at the place x put ln x, what we are getting? Sin of ln x. Okay na, g of fx is equals to sin of ln x. Now this is the composite function. Now can you find the domain of this one? Obviously you can't put x as negative, because if you put x as negative, then ln x is not defined. If this one is not defined, then how can you get total value of sin of ln x? Okay, so one thing is clear, domain of composite function is always subset of domain of this one inside function. Okay na? You can't put any value of x which can't be received by fx. Okay, so one thing, first x goes to f, so f can take or f can receive the values only from its domain na? Okay, so domain of this complete function is always subset of domain of f. Okay, similarly domain of f of gx is always subset of domain of z. You can't put any value of x which can't be taken by z. Okay, so first note I am writing that domain of z of fx is always a subset of domain of fx. Okay, domain of g of fx is always subset of domain of fx. And second point, now suppose x goes to f, then you are getting fx, then fx goes to z, then we are getting g of fx. So at the end value is given by z, at the end value is given by z, and g can't give a value which is not in range of z. Okay na? Suppose like this one, I am taking g as sine and fx as e power x. Okay, g as sine and fx as e power x. So put any value of x, doesn't matter, but at the end you will get value of sine. Okay na? Put any value of x, but at the end you will get value of sine, and sine can give you value from -1 to +1. Okay, it means one thing is clear, you can't get a value which is outside the range of sine x. Okay, because at the end value is given by sine. So I can say that range of g of fx is always subset of range of g. Okay, so range of g of fx is always subset of range of g. Okay, so for composite function g of fx, domain is always subset of f and range is always subset of g. Okay, because when we are putting any value of x, first x is received by f, so f can't receive any value which is not in domain, so domain is always subset of f, and at the end value is given by z, and g can't give any value which is not in range of g, so range is always subset of range of g. Okay, so simply this one we have to remember now. And one thing, suppose I am taking g as ln, g as ln, and fx as minus of e power x or 2 power x. Okay, here g is ln x and fx is minus 2 power x. Now actually in this case this one is not defined. Okay, why? Because put any value of x, 2 power x is always positive, exponential na, always greater than equals to greater than 0. Okay, so put any value of x, 2 power x is always greater than 0. If 2 power x is always greater than 0, then minus 2 power x is always less than 0. This one is always negative na, and logarithm is not defined for negative values. Okay, it means at this time you can't put any value of x, it means function is not defined. Okay, so see here gx is, in this case gx is equals to ln x and fx is equals to minus 2 power x. If you see fx and gx both are defined, but it's in the composite function of f and g of fx. Okay, this one is not defined. Okay, why this one is not defined? Because we are not getting any value of x, for that you can get a value of ln of minus 2 power x. Okay na, because for every x this one is positive, minus of 2 power x is negative, and logarithm is not defined for negative values. Okay, so there is no any one pair x comma y, so this function is not defined. Okay, so simply how, when the function is not defined, when the composite function can't be defined, actually ln can take value from 0 to infinity, ln is only defined for positive. Okay, and value of minus 2 power x is minus infinity to 0. Okay, ln can take only positive value and this one is only negative. Okay, minus 2 power x, it means this one, value of this one is negative, it means range of fx is negative, range of fx, value of fx na, value of fx minus 2 power x is negative. Okay, range of fx is negative, and domain of ln, it means domain of gx is positive. So if range of fx, if range of fx is not belongs to domain of gx, okay, sorry, or in other way, here value of fx is always negative and gx can take values only positive values. Okay, so if you take intersection, in this case intersection of range of fx and domain of gx is equals to phi. Okay, there is no common point, this one is always negative and it can take only positive value. So if intersection of range of fx, value of fx, and domain of gx is equals to phi, then composite function g of fx is not defined. Okay, so I am writing this one. If range of fx, intersection domain of gx is equals to phi, then curve is not defined. Okay, or simply also I can give you example in this one. See, first x is received by f, then here we are getting fx. Now fx goes to z. Now suppose fx can take those value which is not in domain of z, then z can't accept the value. Okay, because z can take only values from domain. Okay, if fx is completely outside the domain of z, it means their intersection of range, value of this one range and domain of z is equals to phi, then it can't accept any value of fx, then you can't get g of fx, it means function is not defined. Okay, so write down. Now we will take some question, after that we will take properties, because directly you can't understand properly properties now. So I will take first question, then I will discuss the properties. Okay, so any problem in this one? Write down. And actually these points also will be clear after the example. Okay, but just simply remember g of fx, these are the composite function. Okay, can I rough? Okay. Okay, see, I am taking a question. Okay, otherwise can I take first theory, then we will discuss example. Now first example. So first question, if fx is equals to x square plus 1 and gx is equals to sin x minus 2, then find f of gx and g of fx. Okay, now just find, it means there is no need to check that f of gx is defined and g of fx is defined or not, actually they are defined. Okay, so no problem. So first if you want f of gx, then this is equals to f of gx, just put the value of gx, gx is equals to sin x minus 2. Now you want value of this one, actually we have value of x, but at the place of x what we have, sin x minus 2, so just replace x with sin x minus 2, at the end you will get value by using f na. Okay, so just put in this one what is the difference, at the place of x what we have, sin x minus 2, so replace x with sin x minus 2, so what we are getting, sin x minus 2 whole square plus 1. Okay, so this is the g of f of gx. Now next one is g of fx, this is equals to g of fx. Okay, value of fx is x square plus 1. Now I want value of this one, actually we have value of gx, at the place of x what we have, x square plus 1, so replace x with x square plus 1, then we are getting sin of x square plus 1 minus 2. Okay, so easily we can find the g of fx and f of gx if functions g and f are given. Okay, so there is no problem. Okay, done. Now next question. If a domain of fx is 0 comma 1, domain of fx is 0 comma 1, then find domain of f of e power x, then find domain of f of e power x. Okay, now simply see. F of e power x, here it is given that domain of f is equals to 0 comma 1. So, if domain of f is equals to 0 comma 1, it means f can take only values from 0 comma 1. Okay, na? Domain of f is 0 comma 1, it means f can take only values from 0 comma 1. So, domain of this one is 0 comma 1, it means this must be belongs to only 0 comma 1. It means you can put any value of x such that this one is outside 0 comma 1, because if this one is 0 comma outside the 0 comma 1, then f can't give you value. Okay. So, domain of this one is 0 comma 1, it means e power x must be between 0 and 1. But we want domain of this function, domain it means value of x. Okay. So, we want value of x from this inequality. So, I have to take logarithm because x in power with base e. So, take logarithm, log 0, log e power x, log 1, okay, with the base e. Okay, e base is greater than 1, so sign of inequality remains. Log 0 is equals to minus infinity, log e, this one is x and this one is log e1 is 0. So, x belongs to minus infinity comma 0. Okay, so domain of f of e power x is minus infinity to 0, where domain of f is 0 comma 1. Domain of f is 0 comma 1, it means you can't put any value of x such that this is outside to 0 comma 1, because f can take only values from between 0 and 1. So, this must be between 0 and 1 and then solve the inequality. Okay. Next. Question number 3. If f x is equals to e power x and this is defined from r plus to r. R plus to r plus it means positive real values, also you can't include 0, okay. It means open interval 0 to infinity, open interval at 0, okay. Remember 0 is not positive and also not negative, okay na. If r minus then less than 0, r plus then greater than 0, okay. f x is e power x is defined from r plus to r and gx. Gx is equals to sine inverse x defined from minus 1 comma 1 to pi by 2 minus pi by 2 comma pi by 2. Okay. Find the domain and range of f of gx. Find domain and range of f of gx. Okay, now this is important. Now actually na, from this question we can also clear these 3 points that is written after pictorial diagram na. Okay. So we want domain and range of f of gx. So first choose anyone, domain or range. Actually first domain, because range is all possible value of y, but you can't take any value of x now which is not in domain. So first we have to identify the domain. Okay, so first find all possible value of x. So first domain of f of gx. Okay, so first I am taking for domain of f of gx. Okay, now I said now one thing that for domain move from above to inside, okay, outside to inside, okay, sorry, outside to inside, and for range inside to outside. So first I have to move from outside to inside, okay, outside to inside, just apply the condition. First function is f, okay, after that we are getting gx. So condition for f, now it is given. Now if you see f is defined from r plus to r, it means domain of f is r plus, okay. So this one must be positive. If this one is negative, then f can't take negative value now, because f is only defined at this time for positive value. So this gx must be belongs to r plus in domain, it means greater than 0 and less than infinity. Okay, gx must be greater than 0, but can't be greater equals to infinity now, so less than infinity. Now what you want, value of x, domain it means value of x now, this one I am applying the condition. Okay, now put gx, gx is sine inverse x greater than 0 less than infinity. Okay, sine inverse x, inverse trigonometric function. Now actually what you want, value of x, so I have to take sine. Okay, take sine, but 1 minute, sine inverse x 0 to infinity. But here if you see in this chapter, after some lectures, you will get that sine inverse x can take only value from minus pi by 2 to plus pi by 2. Range of sine inverse is minus pi by 2 to plus pi by 2, it can't be greater than plus pi by 2. Okay, na? And also here written, this one is the domain and this one is the range. Range of sine inverse x, value of sine inverse x is minus pi by 2 to plus pi by 2. So, the sine inverse x can't take value greater than pi by 2. So, here I have to limit at pi by 2 na, okay, with equality sign. Okay. Now, take sine on both sides. If you take sine, then sine pi by 2, sine of sine inverse x is equals to x, and here sine 0. So, what we are getting, sine pi by 2 is 1 x and this one is sine 0 is 0. So, domain is value of x. So, what we are getting, 0 comma 1. Okay, 0 comma 1. Now, what we want, range, range of f of gx. To find the range of f of gx, first find this function, okay, f of gx. So, if I find the function f of gx, value of gx is sine inverse x. Now, you want f of sine inverse x, at the place of x put sine inverse x, e power sine inverse x. Okay. This is the f of gx. Now, I want range, it means all possible value of this one. Okay. So, just fine, for this one now we have to take inside to outside. Okay. Now, first x, here x from domain, you can't take outside domain na. So, we know that x can take only value from 0 to 1, this one na. This is the value of x domain. Okay. Here we have sine inverse x. Now, take sine inverse. If you take sine inverse 0, sine inverse x and sine inverse 1. Now, actually after some lecture you, in trigonometric function, you will get that sine inverse is increasing function. So, sine of inequality remains same. Sine inverse 0, sine inverse 0, how can you find? How to find? Find the value of theta such that sine becomes 0, that is 0 degree na. So, sine inverse 0 is 0. Okay. Sine inverse x and sine inverse 1, where the sine is equals to 1, pi by 2. So, this one is pi by 2. Okay. But we didn't want value of this one, we want value of e power sine inverse x. Now, take e power. Okay, I am taking function e power of these all. So, again e power x is increasing function. So, sign of inequality remains same, e power 0, e power sine inverse x and e power pi by 2. Okay, e power sine inverse x, now this is f of gx. F of gx, 1 minute, f of gx, e power 0 is 1 and this one is e power pi by 2. Okay, so range is equals to minimum value is 1, open interval, maximum is e power pi by 2. Okay, done. Write down.